Hello and welcome. I am Sohail Taj Darbar presenting you a lecture on one of the core subjects of civil engineering, is that the building materials. The whole syllabus has been divided into 5 headings based on different types of materials used. The headings are like bricks and timber, cement and lime, then we have concrete and advanced materials, then we have floors and roofs. Floors and roofs is a chapter that is based on construction, and then we have all finishes and temporary works. So let's start with the first chapter, is that the bricks and timber. First of all, let's discuss about what are bricks. Bricks are considered as the basic building blocks of all constructions. Bricks have been used since ancient times as the construction material, may it be the ancient Egyptian civilization or the Indus Valley civilization, making it the most practiced and abundantly building material used. Bricks are defined as structural building blocks or units of clay by molding the clay, then drying and finally burning. Now a question arises that there are many kinds of materials available, then why are bricks so abundantly used? This is attributed to the number of factors like availability of clay, which is a universal material. Unlike stones, which require stone quarrying, or concrete, which requires different processes before being used as a construction material. Another important factor that makes building bricks as the most importantly used building materials are size, shape and handling. They have a convenient size and shape, as clay can be molded into desired shape, the standard size being 19 into 9 into 9 centimeter. Then bricks are also cheaper as compared to stone masonry or concrete. As well, there is no requirement of any shuttering like in concrete. Bricks are obtained by molding clay in rectangular blocks of uniform size and then by drying and burning these blocks. As bricks are of uniform size, they can be properly arranged. They are also light in weight, and hence bricks replace stones. Then we have the composition. What should be the composition of the clay earth that is being used for the construction of bricks? For making a good quality brick, it is essential to use the desired type of clay with particular chemical composition. Clay is a naturally occurring material, chemically hydrous aluminum silicate, and the contents or the composition of the clay is like alumina, silica, lime, oxides of iron and magnesia. Now first of all, the alumina content. It is responsible for giving it the plastic character during molding. When alumina is higher than 30%, the brick will become more plastic and shrink more on drying, which finally develops cracks on drying, which is undesirable. If alumina is less than 20%, the clay may be difficult to mold and it might not give a proper shape. Hence, it's required that the alumina content should be between 20 to 30%. The constituent imparts plasticity to the earth, so it can be molded. Then we have another content, that is the silica content. Silica is responsible for imparting the quality of hardness and strength to the brick. It is responsible for resistance against shrinkage. However, when there is exceptionally higher content of silica, the brick may not be moldable, as well as it develops pores, and the mean content of silica present should be 50 to 60%. Then we have another important constituent, that is lime, which should be present from 4 to 6%. A small quantity of lime is desirable in finely powdered state. It prevents shrinkage of raw bricks. And when we talk about the oxides of iron, a small quantity of oxide of iron to the extent of 5 to 6% is desirable in good brick, to impart the red color to the bricks. Iron oxide basically imparts red color to the bricks and lower down the softening temperature of silica during firing. Excess of iron oxide is undesirable as it deforms the shape of the brick, and bricks may even acquire darker shape. A deficiency of iron oxide makes the brick burning difficult and even gives it yellowish color, which is undesirable. Then we talk about the magnesia. A small quantity of magnesia in brick earth imparts yellow tint to the bricks and decreases shrinkage. But the excess of magnesia decreases shrink, leads to the decay of the bricks. Now what should be the characteristics of good bricks? Okay, the first of all, let's talk about the physical characteristics. There should be the physical characteristics. Then we have the mechanical characteristics as well. If we talk about the physical characteristics, they include the shape, size, color, density, etc. of the brick. Shape of the brick is truly rectangular with well-defined edges and corners. In India, the recommended size of ideal brick is 19 and 9 into 9 centimeter, which with mortar joint gives net dimension of 20 into 10 into 10 centimeter. 500 such bricks will be required for completing 1 meter cube of brick masonry. The recommended size of less use are also available, but they are not so much of importance in India as they are used in other countries as well. 22 into 10.5 into 7 centimeter bricks can also be used. Now, what should be the characteristics? The brick should be table molded, well burnt in kilns, copper colored, free from cracks, and with sharp and square edges. Bricks should be uniform shape and should be of standard size. And bricks should give clear ringing sound when struck against each other. If we struck two bricks against each other, they should give a sharp ringing sound, but not a metallic sound or dull sound. Okay. The most common color of building bricks is red. It varies from deep red to purple. Very dark shade indicates overburning and yellow shades indicate underburning of the bricks. Bricks should be sufficiently hard. No impression should be left on brick surface when it is scratched with fingernail. Okay, and bricks should be of low thermal conductivity as well as they should be of soundproof. For that we can use the hollow bricks as well. Now, bricks should also not break when dropped flat on hard ground from a height of about 1 meter, and when soaked for 24 hours in water, they should not show deposits of white salt, which is called as efflorescence. And bricks should have a crushing strength of about 55 kg per centimeter square. Now, there are some standard tests have been conducted by IS 1077-1970 on the bricks, and the most important tests include the compressive strength test and water absorption test. If we talk about the compressive strength test, or first of all, let's talk about the water absorption test. According to IS 1077-1970, there's a procedure for conducting this absorption test. Like, we take 5 bricks at random. Dry the sample to a constant weight in ventilated oven at 110 degrees centigrade for 48 hours. The specimens are weighed individually after cooling, and the dry weighed samples are then immersed in water at the room temperature for 24 hours. After 24 hours, the samples are taken out. Each of the sample is weighed within 3 minutes after taken away from the water. The absorption is given by W2 minus W1 divided by W1 into 100, where W1 is the dry weight and W2 is the weight after immersion in water. The mean of the 5 values is taken as % of water absorption. Then we have the compressive strength or the crushing strength. We take the 5 bricks at random, immerse them in water for 24 hours. After 24 hours, they are taken out and they are frogs. Frog is a depression, basically a depression over the brick on which the numbering of the brick may be written. After 24 hours, they are taken out and the frogs being filled by 1:1 mortar. 1:1 means we take one volume of sand and 1 volume of cement. And these bricks are covered by sack for 24 hours. The bricks are taken out and covered by 2 plywood sheets and then directly tested on a UTM or a CTM. UTM means universal testing machine and CTM means compressive testing machine. And the load is applied actually at a uniform rate of 140 kg per centimeter square per minute. The loads at which bricks get broken are divided by the area of the cross section, gives a compressive strength, and arithmetic mean is calculated for the 5 bricks, which gives standard compressive strength of a brick. Then we have different types of bricks have been used, and there are special types of bricks as well. Now, bricks are made in wide range of shapes and they suit the requirements of the location where they are to be used. Wherever we require the bricks, for example, we require bricks in the coping, we require bricks in the walls, we require bricks in the partition walls as well. Special forms of bricks may be needed due to the structural consideration of the ornamental decoration as defined by the architect. Specially molded bricks avoid the cumbersome process of cutting and rounding the rectangular bricks to a desired shape. Now we have different kinds of bricks. First of all, we have the square bricks, we may have perforated bricks, we may have hollow bricks, and we may have channel bricks. Now what are sequent bricks? These bricks are made in a variety of shapes and are used to the construction of cute and obtuse sequent coins. Then we have the bullnose bricks. Bullnose bricks are also used. These bricks are used to form the round cones. Then we have the perforated bricks. In these bricks, cylindrical, rounded, or rectangular holes are made in the brick after molding stage, called perforations. These are properly placed at a distance of 15 mm from the side of the brick, and distance between any two perforations shall not be less than 10 mm. The major advantage being they are light in weight, less quantity of clay is required because due to the perforations, and they have the least efflorescence. Then we have another type of brick, that is the hollow brick. They are also called cellular or cavity bricks, and its weight is almost 1/2 or 1/3 of the solid brick. These bricks are made of clay and are provided with one or more cavities. Hollow bricks are light in weight and are used to increase the insulation against heat and damage because they are hollow from inside. Then we have the classification of the bricks. Bricks have been classified into 4 classes based on the different characteristics. They may be the first class bricks, they may be the second class bricks, then we have the third class bricks and fourth class bricks. If we talk about the first class bricks, they are well burnt with even surface and rectangular shape, and compressive strength shall not be less than 140 kg per centimeter square, and absorption after 24 hours shall not exceed 20%. When two bricks are struck together, a ringing sound should be produced. If we talk about the second class bricks, they are well burnt, even slightly overburning is acceptable, and metallic ring should be produced when two bricks are struck together, and surface may be slightly uneven. Compressive strength should not be less than 70 kg per centimeter square, and absorption should be from 20 to 22%, and slight fractures are admissible. Then we have the third class bricks. They are poorly and unevenly burnt and overburning. They may even be overburnt or underburnt. Okay, on striking, a dull sound may be produced with non-uniform appearance. They are with non-uniform appearance, or they may be irregular. Then we have the fourth class bricks. They are irregular in shape and dark in color, and with more compressive strength, about 150 kg. It's unacceptable. They have the more compressive strength is at about 150 kg per centimeter square, and they are used basically in the foundations where there is a large amount of load comes from over the structure.